Welcome to another episode of the .NET Show. Now, we've been getting a lot of requests from people to talk more about the architecture of applications, tell people to understand how writing a .NET application can be assisted through understanding the application architecture necessary for it. Now, that's a big topic, and it's more than we can handle in a single show. So what I'm going to do in this show is take and cover the overall understanding of what is application architecture and why it's important for you to think about it and understand what it means to you as you develop your application. But before we get into that, let's go check in with Erica and the news.
Hello, I'm Erica Wiechers. Welcome to the MSDN News Update. In April, Microsoft and IBM announced a proposed strategy for addressing security within a web service environment. The proposed architecture and roadmap defines a comprehensive web service security model that supports several popular security models and technologies in a way that enables the development of interoperable, secure XML web services. Even if you couldn't make it to this year's Tech Ed, you can still find all the highlights on Microsoft.com. You can learn about the product announcements, third parties that have adopted .NET, and the keynote speeches that unveiled Microsoft's vision for the future of computing. You can find a link to these highlights in the transcript. In April, at the Microsoft Mobility Developer Conference, Microsoft announced the creation of Mobile to Market, the marketplace for mobile applications, which enables a process for the certification and market delivery of network-ready wireless applications for the Windows-powered Pocket PC and Smartphone 2002 software platforms. Mobile to Market will supply independent software vendors and mobile operators with a streamlined infrastructure for the certification of compelling and reliable mobile applications. Also at the Microsoft Mobility Developer Conference, Microsoft announced the beta release of the Microsoft .NET Compact Framework. The .NET Compact Framework is Microsoft's mobile application platform technology that harnesses the power of XML web services on mobile devices. As a subset of the .NET Framework, the .NET Compact Framework shares the same programming model and application development tools, enabling .NET developers to transfer their existing skills to build mobile applications. Be sure to check out the transcript for links to more information on these news items. This has been the MSDN News Update. I'm Erica Wiechers.
Welcome back. Like I said, in this episode we're going to talk about application architecture and how that relates to writing a .NET application. And with me to help me talk about this, I've got Shaun Hess, Maarten Mullender, and Keith Short. Why don't you just kind of briefly introduce yourselves and let us know exactly what you do and why what you're doing has anything to do with application architecture.
Okay. I work for the Prescriptive Architecture Guidance Group, which is part of the Content Development and Delivery Organization. And what we're doing is actually, our responsibility is to go and build out actual instances of the application architecture that Maarten and Keith are helping to describe, and provide that as a set of either what we call application building blocks or architecture guides on MSDN.
Okay.
I work for the .NET Strategy Group, and our task is to define the architectural guidance that should be given to the field and partners. And so we define the content and hand it over to Shaun to bring it in a form that people will really understand.
So I work in Visual Studio in part of the group there that's called Enterprise Frameworks and Tools. And our mission is to provide tools to help architects and designers really think hard about architecting significant applications. So we work with these guys to figure out what the problems are that folks are having right now and how we can take some of that guidance and experience and burn it into tools in the future.
So what exactly it is about application architecture is important to understand. If I work at a company like Boeing or some other company like that, and I'm getting ready to write an application, why is application architecture important to me?
Well, I think it's very important to know how it would interact with the rest of the system. You always have an existing system. You plug in something new, and well, if it's a standalone thing and it's not too big, then why worry? But if it has to work with the rest, then I think you do want to worry, and you want to make sure that it does work with future developments. So it's basically everything comes together at some point. You have to write it, you have to maintain it, you have to deploy it, you have to manage it, and you have to change it after a while and still make sure that everything works. And if you do have a good architecture, then there are some constants in what you've done. And if you don't have a good architecture, then you keep changing the whole application all the time, which is probably not very efficient.
Well, one way I like to think about it is that architecture gives you the big picture view of your application as a whole. So when you're thinking architecture, you're not just thinking one element of the application, you're thinking about all of the elements of it. You're thinking about how you're going to take the functionality of that application and break it down into smaller modules. How do those things then talk to one another? How do you get all of those smaller parts to collaborate to fulfill the whole mission of the application? So architects tend to think about that big picture, and they like to have tools that help them see the big picture and drill into specific parts of it. So to be interested in how you take an understanding of what the application is trying to do and say, segment it down so that this part of the application architecture does this part, this other part does some other piece of the logic, and then how do these all work together to actually get the thing to support the business application that's required.
Yeah, is there like, one mindset you need to be in when you're developing an application architecture like that? I mean, I kind of think of something like, let's say, running a restaurant or something like that. You've got the front of the house, you got the back of the house, you got to deal with, buying your fresh produce and printing the menus off and getting your tills cashed out and stuff like that. And there's just kind of a standard flow that everybody opening up a restaurant, whether it's a French restaurant or Italian restaurant or Japanese restaurant, kind of does about the same sort of stuff. Is application architecture the same regardless?
Well, I mean, I'd pick up from where Keith said is it provides the context. And, for us in the prescriptive architecture group is our guidance is actually provided in the context of a meaningful customer scenario. So one of the elements is we need to provide both context and perspective for our advice so that we can help them understand the model that they're working within, typically the business problem that they're trying to solve, and then show them how the set of logical services are actually going to fulfill the business requirements, and then help them understand how they would actually go and deploy that on a physical infrastructure. In order to provide a prescriptive path for our customers, we need to be able to describe both the scenario as well as the architectural elements and put them together into the prescription for the customer.
Now, you use the word prescription quite a few times there. How does that really apply to application architecture?
The way we think about it is when we're typically going through this is that for each place where you typically have an architectural decision, design decision to go and make, we'll try to expose the paths that you have available to you and explain what are the benefits of choosing each of the possible alternatives and saying, this is why we made this selection, and we tie it back to what were the business requirements that you were actually trying to fulfill, so we can eliminate the paths that might not have created the result that you were looking for, and showing you the one way in which we think will actually deliver the result, or at least the predictable result, based on the business requirements.
Well, helping you to make a trade-off. I think architecture is all about making trade-offs. And so you have to have the information to make the right trade-off. And to get back to the question, I think the architect works with the whole and with the parts. So you have to have the whole picture, and you have to be able to just go into every part of it. You have to be able to think about how people will develop the software, but you also have to be able to think of how people will deploy the software and how it will run in the organization that you're targeting, which may be completely different for different organizations.
One of the things that we've found is that the more people who are designing architect up front, when they're just trying to lay out as I said earlier, the big picture of the application, the more that they can comprehend how that application is going to be deployed on an actual physical data center architecture, then the better informed they can be in terms of making choices about application architecture. So it's almost like thinking the big picture from just the functional requirements of the application. If that can be fed in with knowledge of how that application is likely to be deployed, then you get an application that's better structured and has fewer problems when you actually come to deployment. So there's a very important sort of loop closing aspect of thinking about architectures from different perspectives.
What sort of things would a person need to understand going into this process? about their needs of their application, or to even begin thinking about the architecture? I mean, like, let's say, I wanted to develop an application. I came to you guys, said, hey, I want to do that. I want your help in architecting this application. What would be the first questions you'd ask me?
Why do you want to build it?
So, what is the solution you're trying to solve, the problem you're trying to solve?
What is the problem you're trying to solve? Basically, I would start with the business problem. What are you trying to solve? And that immediately sets, like for instance, how much you would like to invest in doing it. So it sets a lot of boundaries immediately. So I think that's the very first question that I would ask.
Yeah, I'd kind of echo with Maarten. Is the way we're thinking about describing architecture is that there's three levels at which you're typically dealing with, or at least three views. First is at the business or the conceptual layer, so we can describe the business process that's being implemented. Second is around a set of logical services that are required to fulfill the needs of the functional requirements of the system. And then finally, the runtime or the physical deployment environment. So it's all three of those together in their interaction that you need to be able to trace from the business requirements to the set of logical services, and then finally to the ultimate physical deployment environment. That's important. And you need to be able to show traceability from top to bottom there.
Well, I see the problem actually slightly broader than that. In many cases, you have a deployment problem or you have a management problem. So the business problem stays the same, but you just have too much cost.
Yep.
And that's a problem, so you have to do something about it. So it's really the business problem that you're looking into, and not only the business scenario, but the real business problem. Why is there a problem? Why do they want to do something? And I think that sets the scope of the whole project and the way you think about it.
One of the things that we're trying to encourage people to think about when they're thinking architecture is to think not just the functional requirements that the application has to fulfill, what business problem is being solved, what is the business process, what's actually happening, and so on, but to think about the non-functional requirements, such as performance and reliability and how easily it's going to deploy, how well will it be managed in operations, and so on. There's a whole lot of aspects towards thinking about the shape of an application that are driven by conceiving those as early as possible in the process. So that's an important split of perspectives, and one that we certainly want to encourage more people to think out beforehand. I think traditionally folks have tended to think of the functional requirements early, and you've done a reasonable job of getting those mapped out before application design and coding begins. But then often, in fact all too often, the non-functional requirements are kind of an afterthought, and then that's where performance and scale and operations problems start to crop up, because those weren't considered early enough in the process.
Wouldn't something like performance and scale, wouldn't you just want, total performance and total scale? I mean,
well, it depends on. Yes, everybody would like the best of
yeah.
everything, but sometimes there's a cost factor, and sometimes you need to understand what's good enough for the particular needs of that business. So it's important to have a good understanding of what those non-functional requirements are at the earliest stage possible.
And I think that's also what the main thing that we're working on. If you talk about services, and .NET is all about services, if you talk about services, then you're really talking about that separation. You're talking about the separation of the functional requirements or the business functionality and the non-functional requirements, or I would say the operational functionality. And services give you really the opportunity to separate those out. And now you can have different sets of people really thinking about the business problem and solving the business problem, and you can have other people thinking about the operational aspects and solving those. And of course the two groups have to work together, but there's less of a dependency than there used to be in the past. And
wouldn't the services model add an extra complexity to it, though, because now suddenly you have these reusable services, where maybe one of the goals you have is say, okay, I want to develop this application, but I want to try to reuse all the services as its other project was using.
And that's exactly where the trade-off comes in again. I think architecture is all about trade-offs. It's making the right trade-offs. And yes, services are, well, since services are message-based, that's the assumption, right? And service or messages are difficult to deal with, because now you've got two things running in two different places and at a different point in time. So this one runs first and then that one. There's a message in between. So yes, it's more difficult. Error handling will be more difficult. Transactions will be more difficult. But for that cost, you also get a benefit. You get this loser coupling. You lose the binding to specific technologies. And you get this separation of functionality and operational aspects.
Actually, although you mentioned reuse there, Robert, I think it's important to point out that although reuse is an important attribute of thinking about a desirable architecture, it's not the driving, probably not the driving goal for most folks. Reuse is actually extraordinarily difficult to achieve. I think the service-based approach that we're beginning to explain to folks about, what .NET can offer, will assist in people getting higher degrees of reuse. But I think there are a lot of other benefits, such as the one Maarten was highlighting there, of looser coupling between things, being able to repartition an application onto multiple servers, for example. All those are perhaps stronger, earlier desirable goals than reuse is going to be for most enterprises.
But reuse sounds like such a low-hanging fruit. I mean, you can really understand the recycling and reusing existing technology.
It's been hanging low for 2 or 3 decades. That's the problem.
Well, the problem is always you have to use it first, and then you can reuse it. And getting it to make something usable is always a pretty big hurdle. So
the problem that we typically face in the prescriptive architecture group is how do we go and look at multiple customers that had a similar set of problems and then factor that down into what were the elements of that problem that were similar across multiple customers, and then prescribe a path that is likely to be able to be followed by multiple customers. But it's incredibly hard. You need to bound it by the scenario and actually pick both your starting and ending point and guide people through that process. And the way we think of it is it's better to show a customer a path through with an identified set of requirements and allow them to understand how the points of variability exhibit themselves in their environment and then make the changes that are appropriate. But complete reuse is actually a very hard task to go and accomplish because the customer's requirements tend to be very specific. It's kind of hard to engineer it in Redmond.
And it's only partly a technology solution to reuse, as I think most folks appreciate. A lot of it's about cultural inhibitors in an organization, for example.
What do you mean exactly by that?
Well, it's actually hard to get one part of an organization to build something that another part will then use. That's just been a classic problem of design and implementation.
Like a not invented here sort of concept?
Mostly, yeah. But also that, as Shaun was pointing out, requirements are subtly different and nobody's willing to take the extra cost to make sure that this thing can be then reused in these 2 or more places. I mean, there are plenty of enterprises we speak to who have been very successful at reuse, but it's not easy and it's not cheap.
So it almost takes an Uber architecture, thinking about the bigger problem, about just the overall solutions this company is solving in total, rather than individual problems.
Exactly. I think you're likely to be more successful with raising the level of reuse if you've got this big picture of the of all the assets that are inside an enterprise, or those that are planned and exist today. That if they can fit into something that is structurally well set against the background of the needs of the enterprise, then reuse tends to be something that is more achievable than if none of those things were present.
Yeah, I think it's more about identifying the integration points and the interfaces that are supported and how you can connect things up in different ways than actually trying to reuse components into another application context.
It depends what you want to reuse. If you look at the financial administration, then yes, you want to reuse that across enterprises. So an ERP system will be sold to many enterprises, so that obviously has to be reused. But if enterprises write their own components, then reuse is very often not the first thing that springs to mind. But the integration point is, so how can I tie my own process into the financial administration? Because what I do has a financial effect, so it needs to be in there. How do I do that? How do I manage that? I think that's more of a challenge.
The one place we feel like we've been a little more successful is we have a series of deliverables which we call application blocks for .NET. A good example is the data access block. That's an area where nearly every enterprise will have a similar set of challenges around how to instantiate their data access methods within their applications. The set of choices is smaller and more bounded and better understood, so it was possible for us to go and build code that could be easily dropped into multiple applications and easily modified by developers in different organizations. But it takes a problem that's fairly well bounded and understood to sort of promote a reusable component such as that.
But reusable design is also a very good thing to strive for, and I think that's easier to accomplish.
Yes.
Because that's basically what you do in the prescriptive architecture.
Yeah. we'll
So what do you
typically
mean by reusable design then?
yeah, we'll typically deliver the design elements, which is typically delivered in you know, Word doc form. You know, it's guidance, it's a guide that goes along with it, and we'll also deliver the code. So we'll allow people to pick up either just the reusable design guidance or architectural guidance and use that independent of the code that we've delivered for the folks that think that the code that we've actually given them as an example of instantiating that design, they can actually get the source code off MSDN, go and build it into their application, modify it for their particular use, and use it as part of their application. So we think there's customers that fall in both categories, that some will find the design to be important, and that's as far as they want to go. Some will actually take the design plus the actual code that we've provided. So,
and picking up from that, from the tools perspective, we want to try to build on the experience that the PAG group has in talking to customers who've got problems with building apps today, and really distill from that what we call patterns. So we're looking for recurring common elements across multiple application solutions and seeing if we can extract from that things which crop up time and time again. Because if we can understand what those are and kind of codify them and build tool support for them, then we can ensure that future users of the tools will be pretty much guaranteed to adopt best practices in applications they build, because we would have enshrined in the tools these desirable qualities that we spot as patterns that recur across successful implementations on .NET.
So there you're reusing the patterns or the models of an application as opposed to some of the actual functionality of the application.
And that's a topic that people are extremely interested in today, as to how this notion of a pattern, a sort of recurring solution to a theming, a problem in context. Traditionally, I would say perhaps over the last 10 years, you've heard that term cropping up more in terms of lower level programming patterns, which has been pretty successfully adopted in many big enterprise groups. And now we're trying to apply that same kind of thinking to not just pieces of code, but pieces of design, and actually pieces of quite substantial context architectures. So a generic pattern for service and say 3 services which are combining to meet some part of the needs of, say, supply chain automation. We find that those types of services and the things that they do will crop up time and time again. So how can we somehow get that notion into a tool so that we can help folks who want to build applications that in some way are similar to that, can make sure that they build them and adopt the best practices possible.
right. I think Keith makes a great point, which is he's talking about instantiating those patterns into the tools. Is in our role, our objective is to start showing people those patterns before they're actually instantiated in the tool. In order to do that, we need an architecture that we can show people both context and perspective simultaneously, and describe which element of the application architecture are we actually proposing that you use this set of guidance for, and how does it relate to the other elements of your application architecture. We found that we were kind of operating at the individual pattern level, and where customers struggled was, help me understand the bigger picture in which, what are the other patterns that you see, and what have you got planned for us as you go down the road?
Yeah, I think that's an important one. What have you planned? So in the guidance, you have to show how you do it now, and you have to show how it will be done in the future, and how you get from the now to the future.
It's like the roadmap.
The roadmap.
Yeah. How many patterns are there? Are we talking like a dozen, 100, 1,000 different patterns, or is it an unlimited number?
I think in theory it could be unlimited. I think what we're finding is that as we go through, there's probably a manageable number of reusable patterns that we're starting to see with customers. I mean, to date, we've actually delivered against the data access block. We've also got exception management, monitoring, two subjects I think Keith brought up earlier, that we see that there's a recurring way in which we see people implementing those sets of capabilities. We think there's probably another, at least half a dozen that we're going to be going after to produce, again, guides as well as code to help people solve fairly typically recurring problems when they're building basically a .NET application, net new.
Yeah, particularly a .NET application that's composed of a set of web services which are collaborating to get something done. Then we're finding that, say, looking at how, say, 2 of those web services need to communicate and exchange messages to achieve their part of the business process. That quite often those fall into certain patterns, that the structure of messages that they're interchanging, the way that those, the request and the response back from the other service, that you can codify those into a recurring pattern and say that is an interaction that sort of follows this kind of shape, and that can be very useful to help people get sort of off the ground from in terms of supporting their business needs.
So is it like our job as Microsoft to help identify some of these patterns and put them into the tools, or is it merely our job to help the customers and partners understand the importance of patterns?
Well, those are two things, I think. We have to recognize those patterns, and I think nobody just sits behind his desk and thinks, well, let's find a pattern. So what we typically do is we do projects with customers, and we talk to a lot of customers, and we see recurring things, and we just try to abstract those. And then we go around and talk to a lot of architects within the company and just discuss those patterns and see if there's any validity in those patterns or whether they should be changed, and then we try to describe them. So I don't think many of the patterns even come from Microsoft. They just come from experience from customers that do the totally different problems solving same way. So I've been doing a number of projects, and I found that the architectures were reasonably similar, even though the problem space was totally different.
So I mean, something like Excel might have the exact same sort of problem space that mappoint.net might have, or something like that.
Well, I would say at the level of enterprise application integration. So they have their own process, their own vertical market that they've solved, and they want to integrate with a number of other processes or other applications, like an ERP system, like a CRM system. And how do they do that? How do they go about that? Or they've got a distributed environment. If you talk to enterprises, then most of them are reasonably widespread. So they've got different data centers that need to talk to each other. How do they solve that? How do they integrate stuff? And they tend to just do the same kind of things.
I think clearly, as Keith pointed out, is those types of patterns can exist sort of at the code level, typical gang of four level patterns. The things that we're talking about, like the data access block, and really are probably, from an industry perspective, more characterized as frameworks. And sometimes they can exist at a fairly macro level. Good example of that is, Microsoft has a Microsoft solution offering called Microsoft System Architecture, which is really about an internet data center, which is a physical deployment pattern. So we think they exist not only for developers from a coding perspective, but they also exist in terms of the actual deployment architectures and the types of server roles that typically get instantiated in customers, and that you'll see fairly similar sets of capabilities being instantiated over and over and over at multiple customers to solve.
And that's typically what happens. You take a pattern, which is sort of an abstract idea, really. It's like you've spotted something that occurs and some solution to it. But then typically what we would do at Microsoft is figure out what framework we would build that supports such a pattern, so that we then turn the task of building that part of the application that conforms to the pattern as simply being to complete some part of a framework which we then choose to offer. So examples of that are in data access, where there might be a good pattern for how you organize a data access layer inside a business application. What should it do? What things should you put in the mid-tier server versus what goes on the database server, and so on. And you can sometimes be quite prescriptive about a good way of doing those for certain circumstances. But then you don't want to just throw people back down to raw code, so we provide a framework which in effect supports that pattern, and then makes it very easy for our customers to then code to the framework, and then you get the benefits of that pattern kind of given to you.
So I mean, these pattern usages, I mean, are they going to end up being like really complex wizards, or are they more like diagrams or documentation and stuff like that?
depends on the level that you look at it. If you look at the high-level architecture patterns or design patterns, then what you're really looking at is the set of trade-offs that you want to make. If you look at more low-level things like database, then I can imagine having wizards. The whole thing with interfaces, for instance, as soon as you identify interfaces and you identify which pairs of interfaces you've got, you could build tools to just show, well, you can link this to this, but not to that. I mean, those are patterns that are excellent in wizards, and others are just not. It's just look at them, take your own decisions. This is the cost, this is the benefit, and you've got to make your choice.
But I think in reality, they're all of the things you said. Sometimes it's a wizard, sometimes it's a complicated tool, and sometimes it's just a document that helps people think things through and offers guidance. But a good example might be to just ground it. If you think of, say, BizTalk Server as an element of the .NET Server architecture, then if people are trying to figure out how to support a particular business process, they may have identified, say, a bunch of web services that they've divided the functionality across, but now need something that is going to say, now do this, and then do that, and then either do this or that. What you start to surface there is a need for orchestrating amongst a set of web services. Well, that's what one of the things that BizTalk Server can do for you. So you think of now, okay, so the way that I want to describe the interaction between these services and the data that they interchange via messages, that's now starting to fall into this pattern of collaboration between services, and BizTalk is in effect a way of organizing that for you. So you can start up the BizTalk orchestration design tool, and that in effect is going to make sure that whatever you describe there about the interaction between this bunch of web services will conform to a set pattern that BizTalk understands. And when you've completed the design of your schedule and installed it in BizTalk, BizTalk becomes the orchestrator for that collection of services. So, what part of all that was the tool and what was the pattern? At the end of the process, it's scarcely identifiable. You just need to know that if you use this tool in this way, deployed on this server, then it can behave in this way that will organize a bunch of collaborations in a predictable and safe way.
So when you talk about tools, you're not just talking about little, snap-ins for Visual Studio.net. You could be talking about BizTalk or Commerce Server or, IIS or some other things like that, just identifying some bigger problems.
They can be all over the map. They can be substantial tools. My group, for example, is certainly working on some tools that we'll be releasing over the next 1 to 2 years, which we think will be really addressing the need to do some of the things I was just describing, to really understand how to break down an application into a set of web services, try to figure out what part of the business application should go into which service, how they should talk to one another, what are the interfaces, what are these contractual obligations between them, and lead you through a design and development experience that will end up with carefully structured web services, which will be guaranteed to encompass some of the best practices that we learn from these guys over here.
Our goal here is to deliver predictable results for customers. It's not to tell them there's only one way to do it, but to indicate to them that this is a way in which we've tested and it delivers a predictable result consistently for the customer. So to give them a better starting point with a known better result if you follow the prescription that's there, to get a good predictable experience from a customer's perspective.
And particularly we focus on usually fairly substantial IT groups in companies. So we're not really, for the moment, in this conversation addressing, say, a hobby guy working in his garage on his own. But if you look at a traditionally fairly large development shop, then quite often there is a desire to carefully segment a big application down into very small chunks, so that individual developers don't get to make really important decisions about overall architecture of the application. So a tool which will first of all address this, as I was saying earlier, the big picture, but have enough scope within the tool such that you can carve out small pictures from that and hand that over to individual developers who are then unencumbered by some of the implications of broader architectural decisions. That's a a way of working that many big enterprises are extremely comfortable and in fact would like us to do more to help that mode of working.
I'd kind of imagine that for a company like Microsoft to come out with some tools like BizTalk Server and stuff like that, the problems they're needing to solve need to be fairly big problems that a lot of people are facing. And I'm sure there's a number of different architectural niches out there that probably aren't big enough for us to develop a tool for. Are we dealing with third parties in that fashion to understand how they can maybe fill those niches?
Well, enterprises still have their own development shops, and they hire people to do development, and that will be for a long time to come that will happen. So tools hopefully will help those developers as well, but not as huge chunks of just plug it in and it will work. I mean, it's just like, but it will be like if you follow these patterns, if you develop your solution like this, then you've got more chance of success.
Yeah. From our perspective, when we go and deliver guidance to our customers, our target is that we want to allow customers that might decide to deploy vastly different sort of process project methodologies or use multiple sets of tools to go and use that guidance effectively within, say, an environment that they might not be using Visual Studio as their primary target environment, or they may be adding on a tool such as Rational's environment that's complementary to Visual Studios to still be able to use it in those contexts.
Yeah, because one of the things that we're finding is that there are very few green fields left in enterprise development. So a lot of applications are those that fall into the category of gluing existing applications together in a better way. Enterprise application integration is a term often used to describe that. But there's an important set of applications which some folks have called edge applications because they tend to sit sort of outside the edge of the core applications that run the business. And those are the ones that a lot of companies are interested in right now. They've essentially got their line of business applications that run the business. They're interested in building, say, applications that allow, say, employees easy access to accounting data, or customers good access to order data, and so on. So they tend to be the apps that sit between the line of business apps and external users to the company, either a partner or a customer or somebody else. And often those are quite sophisticated applications in their own right. They have their own databases and they have very little legacy there to try to work with. But nearly in all cases, they have to also work with the older established line of business apps in order to get some kind of business process that runs from customer or partner right the way through into the core of the business. So those applications, these edge applications, are a great source for where .NET technology can immediately be brought to bear because it's possible to arrange those applications as a set of services, and by using web service wrappers around older older applications, or those that have to talk to, say, mainframe legacy apps, that .NET now as a set of web services is just an excellent way to begin to think about that problem as a whole and start to glue these things together to provide this additional value.
I think you raised a good point there about using .NET to assist in the process to tie these legacy applications together. What I think I'd like to do now, since we've been focusing so much on just the overall architecture aspects and not really even talking about .NET at all, I think we should save for the second half of the show to talk about .NET and how that brings some aspects into thinking about architecture of applications, and talk about from the programmer's perspective what they need to think about of using the tools, whether it's a language or a particular framework or an approach to writing an application. Well, thanks. So that gives you hopefully an idea about what an application architecture model is and why you need to think about it in developing your applications, plus how Microsoft is trying to understand these application architectures better so we can give you the right tools, documentation, and templates to develop your applications better. So stay tuned. We'll be right back and talk about how .NET plays an important role in application architecture.
Well, time to make the rounds. out your dead. Bring out your dead. Ooh. Bring out your dead. Bring out your dead. Much appreciated. Thank you very much. Bring out your dead. Bring out your dead.
Here's one.
What?
Nothing. Here you go.
Well, now it appears it's not dead yet.
Yes, it is.
No, it's not. And you've got email.
No, I don't. It'll be dead soon enough. Here you go. Oh, sorry. 95 plus pack is installed. Knock it off. You're not fooling anyone. Come on. Do us a favor.
I can't take it. It's against regulations.
Well, can you come back in a couple of minutes? It won't be long now.
I'm already 2 hours behind.
We heard you. When's your next round?
Thursday.
Is there something you can do? Oh, thanks very much.
Not at all. Bring out your dead. Bring out your dead. Anything for us today, Miss Cleese?
Oh, no, thank you.
Oh, of course. I'm sorry we won't be seeing much of each other anymore. Good day, ma'am. She's got Windows XP. Bring out your dead. Bring out your dead. Bring out your dead.
Welcome back. Now in this segment we're going to take and dive a little bit deeper and talk about how the .NET framework specifically plays a role in developing application architecture, as well as some of the deliverables and resources you can find that Microsoft is providing to help you get your applications architected better. So gentlemen, .NET is all about services. I mean,
Yes.
web services and the framework providing services and capabilities. Do services themselves play an important role in thinking about application architecture?
Yes, I think they're the basic building block, and understanding services, when to use services, why to use services, when not to use services, and why not to use them is extremely important. And I think using services is all about coupling to certain. Well, first of all, I should say we see everything as a service. Services talk to each other. So I will not talk about client server. I will talk about two services talking to each other. I think that's an important part to understand. Then services communicate through messages. So if I were to explain the difference between a service and a component, then I would say services use messages. Services are components that use messages. So now the services live on different places, and there is a time difference between calling the other service and executing the function. And it may be a long time if you think about the internet, and it may be an extremely short time if you think about the local deployment. So, but the important thing is that services use messages. Then in understanding when to use services and when not to use services, I think a major point is, do you want to deploy them separately? Do you want to manage them separately, or do you want to manage them as part of a bigger whole? And so there you get the advantages of using services. Another aspect is how loose or tightly coupled are things. I think if you look at what DNA was, WinDNA was about building tightly coupled systems that serve a specific purpose, these three-tier architectures. .NET is all about loosely coupling those tightly coupled systems. So it's not only about loosely coupling systems, it's about loosely coupling tightly coupled systems. So I want to tie an ERP system to our CRM system, and I want to do that loosely. I want to be able to just take another ERP system with the same CRM system and tie them together. And then you get the whole gliding scale. So when should I start thinking about services, and when should I stop thinking about services and think about components? And much of that is based in this loosely coupling that we want to do. But service or not service is just one step in this loose or tight coupling. So what does service infrastructure offer you? It offers you that, well, you can talk from a system that's built in one language to a system that's built in another language. System that runs on one operating system to a system that runs on another operating system. So you have this technical independence, I would say. So it doesn't matter anymore what system you've got there, whether that ERP system runs on Unix or whether it runs on Windows. That doesn't really matter as long as it's hidden behind this server facade, so that I can really talk to it through SOAP or XML. And but that's only one level of loose coupling, because as soon as I say ERP system, then we think of the different ERP systems and we think of the different formats that they use and the different objects that they've got. And then I still can't have two ERP systems talk to each other, even though they use SOAP, because the message formats will be different. And that's where you get into the high-level patterns, such as BizTalk, where you really need to make transformations from one thing to another. So the service doesn't help you. The fact that it is a service doesn't help you there. The fact that it is a service helps you bridge operating systems, encoding problems, basic formats. So it does give you a step in coupling things more loosely than they would otherwise be. And I think that's one of the basic models that we're trying to work through. Another pattern there would be that we don't like to see the surface as a whole. We like to see the surface with its exposed interfaces, so that you can, at a high level, you can think about those interfaces and designing those interfaces. And then once you have these interfaces, you can talk about implementing the service behind it, which means that you've hidden it and now I can replace it. I heard of one enterprise that rolled in a new ERP system, and they had everything nicely behind interfaces, and they only rewrote this one facade for that ERP system for the financials, and from one day to another they just changed the systems, and it worked.
Just by changing the middleman between the interfaces?
Yeah, as well, the interface remains the same, but the implementation of the interface is different, and that's all they needed to do. Well, that was quite a work, of course, but then after that, it was easy.
I think one of the things that we're trying to do here is we want people to see their applications as a set of .NET web services that are communicating, and that's an important aspect that Maarten was picking up, because that's all about loose coupling, message design, really understanding what what XML schemas are being interchanged. Of course, the .NET supplies a lot of tools and technology to help you think through those aspects of the problem. But then also, as you look at any one particular service, it's about drilling into that and what is a good internal structure to a web service that will then have desirable qualities of partitioning, for example, as Maarten was saying. Can I make sure that, say, business logic is not wrapped up in anything that's handling messages? Can I make sure that business logic is separate from anything that's managing underlying data integrity? So these are just good design principles that we want to instill in folks to say that if you build the internal structure of a service in this fashion, it will not only be a better service in its own right, but it will be a better participant in these collaborations with other web services. So .NET provides a lot of features to help you think through those aspects of the problems and get this internal architecture to a web service just right.
Yeah, I think we just touched on a very important one, that is that you could separate your business logic really from your operational infrastructure. I said it in the first part of this session as well. But you can really see them as two separate things, and that is because once you send out the message, you can do whatever you like with it before you deliver it on the other side. So I can transform it to another format. I can put it in a binary form or in a SOAP format. I can put it on a fast line or a slow line. I can make sure that there is a guaranteed delivery and that there's only once delivery and all these kind of nice things. And I can do signing and I can do authentication and authorization just before you get into the other service. And I think that allows you to set, for an organization, to set policy on top of the business logic. So the business logic has nothing to do, or well, sets the minimum requirements, I would say, for the policies that you require, and then the infrastructure around it that takes care of all the messaging can enforce additional policies. So you really have a separation of your business functionality and your operational functionality.
And yeah, that's a good point. And since we shipped Visual Studio.net, at least the enterprise edition of that comes with some features that really assist this kind of architectural structuring that we've been talking about. It's called the Enterprise Templates feature, and hopefully some of the folks out there have actually used this. But what it's trying to do is to establish a project structure inside Visual Studio where the items in the project can contain policy, so that an administrator or an architect can set policy on a particular part of the project structure, which then allows for or constrains, for example, what kinds of things the developer can then add into that part of the project.
So what do you exactly mean? That sounds kind of like...
Let me give you a good example of how that's realized for a developer. Is, some of the assets that we produce, I talked about the data access block, is part of the enterprise template might have a place where it says, do your data access here, is we have the ability to import in that guidance and code as a result of the policy that's been set and the assets that they want to make available to the developer. And the architect is making the decision about, we want to go and implement the data access methodology using this block and this guidance. So the developer actually starts from the place that the architect has defined as, start here, use this to go and build your application. So it's a way for the architect to go and effectively, constrain the way they want the development done so that it's consistent with the policies that they've set for their organization.
So for example, if the architect has created a project structure that clearly identifies where data access should belong, he can set constraints on some other part of the project structure, say a business rules part, and constrain a developer from then adding data access technology into that part of the project.
So you mean like they're making sure that the database isn't open at this point in time and they close it here and stuff like that?
Well, yes, and actually any activity on the database is constrained to a particular part of the project. So if that's the data access layer in this particular architecture, then the policy system of Visual Studio can help both the developer understand what he's allowed to do and have the architect set that policy up in advance. And this has turned out to be a very popular feature that we'll build upon in later releases.
So when we go out and talk with developers who have been developing applications for, Win32 or for other operating systems like that, and we're talking about .NET as an application platform, what are some of the problems you see them being faced with in trying to think about how do we take and use .NET in our application architecture moving forward?
That's a good one. At the low level, well, I've been working on a number of projects where people, for the first time, opened the Visual Studio.net and tried to work with it. And I would say at the programming language level, there is hardly a problem, apart from the fact that if you are used to Visual Basic and all of a sudden you've got Visual Basic with interfaces, and then that's hard, especially if you have, let's say, a VB4 developer. For people that have been working with C++ or Java or well, actually even Visual Basic, for many there is no problem at all on the language side. And where do the problems come in for the developer? I think specifically on where you talk about services. A service is nice and it gives you all this loose coupling and whatnot, but it also gives you this problem that there is a latency between you asking for something and you getting it back, and you may not get it back, or it may be delivered twice over the internet. And those are the kind of things that I think developers run into time and again.
So it's a different model rather than being just an application the developer compile and there's an executable. Now all of a sudden you have the services stuff going on that are on the network or on the internet or even located on the local host of the same system.
And they're often inherently asynchronous, and that walks into a programming model that some developers are not comfortable with. So we have to work a lot harder as we release ongoing capabilities of the .NET framework to make it easy for ordinary developers to engage in asynchronous conversations with other services in a way that is comprehensible and free of problems for them.
Now, on the face of it, I would think of a synchronous application model just sounds so much cleaner. I mean, it's like, I start here, I'm traipsing my way through, I make a call and it comes back and I deal with that result. Where an asynchronous model sounds a little bit more complex, almost like, dealing with recursion in an application for the first time.
Yeah, well, that's very true. And that's also why I think it's, if you talk about .NET, then you're talking about loosely coupling, tightly coupled systems. So you can write part of it tightly coupled, and you can write it with synchronous calls and just not bother about the fact that they perhaps are services. But at some point you have to say, well, this is really a boundary, and here the architect or the designer really draws this boundary and says, well, I want to have this deployed on a different machine, and I may have to have the internet in between, and I may have to have 3 firewalls in between, and I need to have it signed over here, and yes, it's going to be asynchronous. And I think those are the interfaces where you really have to spend time and design the right thing. And then below that, then you can say, well, okay, I've got this box, and as soon as I get in, I start a transaction. And if I get out, I commit the transaction. And if anything goes wrong, well, okay, transaction aborts and nothing happened. So you can still do that. And you should.
Do you end up with a better application because of it, you think?
Yes, definitely. You just have to define your services at the right level, and that's the trade-off that you've got to make. Where do I really need this separate deployment? Where do I really need this this remote behavior, this loose coupling? And where I don't need it, well, it's nice if it's for free, but otherwise just don't bother.
I mean, certainly the .NET framework today contains everything that you need to go program these sophisticated, loosely coupled applications. And it is important. Asynchronous behavior is very important, particularly if you're dealing with, say, B2B applications where you certainly can't be holding long-lasting locks on somebody else's database, or you aren't sure of the latency between a request and a reply back. So they are inherently in those kinds of problems at internet scale. But the .NET framework contains everything that you need to program that, from queue management to XML processing, through to SQL and even BizTalk as a way of orchestrating these complex conversations. The key thing for us, Microsoft, going forward is just to make all of that easier. Everything's there, and what we're really striving for now is to make these complex applications that require very sophisticated developers today to pull off well. To make that easy for ordinary developers, guys like us, to go build these kinds of applications in a very predictable way, as we were saying earlier.
So what are some of the things we're doing to make it easier then?
Well, I mean, part of the goal of my group is to go and deliver some of that guidance that actually will take the canonical architecture that Maarten is describing and what Keith described. There's typically a shape for that application, and the way in which you want to partition the functionality is to actually show customers, given this design that you're actually marching towards, what are the key sets of design decisions you're going to have, what are the options you have available to you, and actually show them what we think is going to deliver a predictable result to solve a specific problem. And it kind of goes back to that concept of a pattern, which is, under a certain circumstance with a particular solution in mind, what do we recommend you go do to get the kind of results? So you can expect to see, a .NET application architecture reference, which is, if you're building an application that looks like this is how we recommend you implement the capabilities across the various layers and the decisions, but also showing them again what it looks like from a deployment environment. So one of the elements is also showing them how does it actually get deployed, so connecting the developer element of it with the IT infrastructure element, so that the customers are also comfortable deploying it. And that's actually an area that we're hearing from a lot of folks that are out there, is they're really still struggling with what's the deployment architecture look like for a .NET application, and it's an area that we're planning to produce a lot more guidance on, which is really about how do you deploy these services, how do you manage SLAs for those services, how do you monitor them on an ongoing basis, so that application developers can actually get comfortable saying there's a service that's out there that I can actually connect up to and take advantage of the capabilities without thinking about rebuilding it yet again. So a lot of their problems are related to the underlying physical infrastructure as much as it is the application development element of it. So we're hearing a lot of customer requests there for information.
Mm-hmm. So this information we're going to provide is going to be like a series of white papers or a big gigantic tome of a book that.
Typically, we have really three basic classes of information that we produce. Some of it's at the architect level, and that's where things like the canonical architecture and the .NET application architecture and things that we call reference applications and reference architectures, which are really describing the major architectural elements and how we see them fitting together and what the basic interfaces are. And think of a reference app as a template that's been filled out to a significant degree that says, start here, there's still areas you're going to have to fill in, complete the functionality to add in your business logic. You're going to have to connect it up to other elements of your system, but substantial portions of code have been delivered. We've published a number of them on MSDN today. At the second level, it's really what we're calling a set of frameworks, and that's where things like the data access block, the exception management block, and some other work we have ongoing fit, which is significant pieces of code that have already been designed to go and solve recurring problems that you'll see many times over. And we'll deliver both a guide, so you can have the information about the design decisions, as well as the code. And you can use each of them individually or together. And then finally is what we call a set of lifecycle guides, which will take a scenario-based approach, which says if you're trying to solve a particular problem, here's how we recommend you get through the planning stage and the set of planning decisions. Here's how you're going to go through the design elements and building your application. Here's how you're eventually going to deploy it. And then finally, here's how do you operate that application once it's in place. So those are the three elements in terms of the architecture pieces, which are really about what is it you need to go off and do, and then the frameworks, and then finally the lifecycle guides. So got a number of them published on MSDN today.
Plus the plan is to make these targeted towards specific application models as opposed to general application design structures, or?
Maarten is actually doing the general application design structure with the canonical architecture, and then the reference architectures are actually targeted at specific scenarios. So this is a way of coupling the principles, a service-based architecture, and the principles behind, why would you design and use a service-based architecture with, specific instances. A good example is, as Keith described, is in developing an edge LOB app. I mean, there's probably a certain, there's a recurring set of capabilities that need to be engineered into that type of an application. And we can say, here's the three problems that we've seen from many, many customers over and over, and what we're going to do is show you what a predictable result looks like based on using the .NET technologies.
How well does the scalability and the performance of applications fall into some of these guidelines? I mean, it's one thing to talk about how you should architect an application, but are we also at the same time trying to deal with how do you make the best performing application you possibly can?
Absolutely. Part of the guidance that we deliver is we'll typically describe to people what were the performance and scalability attributes that we were designing for, what was the SLA that we were designing for. As part of our deliverables, we also release test harnesses and the test cases that we ran against the application, so customers can actually use them to go and test whether or not their particular implementation is performing as expected. So we try to describe that to the best possible degree. What were we designing this application for in terms of the non-functional capabilities, as well as we also try to describe to them what's the target deployment environment. And say many times we'll be targeting the environments that are defined by the Microsoft Systems Architecture, which is a series of physical deployment architectures that we believe represent sort of good, predictable performance capabilities using Microsoft technologies.
So this is going to be a question I probably already know the answer you're going to give, but with .NET, do you think that the underlying architecture of the platform itself creates an even better environment for creating a high-performance, robust, scalable application than other words, or is it just yet another platform people can use for doing application development on?
Would yes suffice? Or? Would yes suffice? I think it depends on the level you're looking at. If you look at the high-level architecture, well, I don't see what's so specific about .NET, but as soon as you start going lower and you say, well, I also like to implement that architecture, then yes, .NET is going to help you immediately, because now all of a sudden services are native, or just native to the environment. XML and SOAP is all native to the environment, so it makes it a lot easier to to build those things, you don't have to worry about a lot of things. And again, you can just concentrate on your business problem and leave the infrastructure to .NET.
A lot of that comes because modern applications are needing to interact with other applications that they need to use XML and SOAP and web-style models for interacting.
It's reducing the dependency on a vendor, and even if we like people to stick to our platform, we don't want to force them to stick to our platform. We just want them to stick to our platform because it's better.
So SOAP has just made, kind of leveled the ground for everybody, and now we have to compete with other platforms by making sure that our platform is the most compelling one for people to come and build these parts of the apps that work with other parts. And from all we're learning of speaking to customers who've been using .NET to build real applications, that we're just off to a great start with the platform right now. People generally have been building very successful applications with it. And I think because SOAP was key to enabling this kind of whole groundswell of web services to grow up, and because XML, of course, as a definition of SOAP messages, because .NET has implemented SOAP to the core and XML to the core, right the way through just receiving a SOAP message at the gateway of a web service, right the way down into the deepest level into SQL Server, for example, that has just made it extraordinarily easy for people to get these collaborating services up and running and deployed into supporting real business apps.
And I think it's important to note that every enterprise has a heterogeneous environment, so they need to have these things talk to each other. So you need some standard, conversation mechanism.
I think an area that we've seen is, particularly around the manageability of the underlying platform, is that we think we can bring some significant advantages to customers if we can show them how to leverage the fact that they can create, say, a common monitoring, eventing infrastructure for their web services-based applications using the underlying platform capabilities. It gives them significant advantages in terms of overall manageability, cost of ownership for those applications. And many times it's just a matter of showing people how to go do that effectively and design their application to take advantage of the platform right from the start.
Okay. Before we close down, I'd like each one of you to tell the audience where you think some key locations they can go to for resources and information if they're interested in better understanding how to architect their applications.
Okay. All of the work that the Prescriptive Architecture Guidance Group produces is published on both TechNet for the IT Pro-oriented topics and on the MSDN site for the developer-oriented topics. I know for developers in specific on .NET, so we have a series of application blocks for .NET that are published on MSDN that people can go off and start using today.
And I'll put a link to those articles
Yes.
on the bottom of the transcript.
Yes.
Yeah, I don't think I've got much to add there. We're working on an architectural site within MSDN, and as soon as we're ready, we'll publish.
So at some point in the future, there'll be some
Some
resources
point
in
in
your
the
group.
hopefully near future, we'll publish. Yes.
Yeah. And I guess our story is a little bit further away because we've just shipped Visual Studio.NET. We're now all working towards the, would you believe, the next version of that.
Never stops, does it?
It never stops.
No, hopefully not.
I just want to emphasize one of the things that I think I said earlier, that a lot of the information that we're getting from the practice in the field and from Shaun's group, that's very much how we're trying to shape the tool set of the future to solve the kind of problems that we see people now having in trying to build these apps on top of .NET.
So you're not just working in a closet someplace where you're actually interacting with real-life scenarios to find out how they can use your tools.
Yeah, absolutely. And we want to try to get as much of those best practices enshrined into tools as possible so that everybody will be able to build great applications on top of .NET.
Okay.
And as we begin to codify those patterns more and more, we'll be using the mechanisms that Shaun and Maarten just described to get those patterns out to people and get feedback as soon as possible.
Okay. Well, thanks. Thanks for joining me and talking about architecture. I know as you come across with additional deep understandings of specific patterns and specific areas where application design, I'll probably have some of you guys back on the show again to talk about some of those specific applications and show some code and stuff like that and how specific application models can leverage the application architecture of .NET to provide better applications. Thanks.
Thank you.
Thank you.
So hopefully this brief introduction to application architecture and how it applies to writing a .NET application can assist you in developing better applications that uses our platform as well as integrates with other people's platforms as well. So thanks for joining us.
In these interviews, you've met the senior producer of the .NET show, the multimedia producer, the audio engineer, and in today's show, I have with me Gary Spradling. He is not only a product designer with the product websites at Microsoft, but he also does the graphics for the .NET show. Gary, welcome.
Thank you. It's a pleasure to be here.
So why don't you tell me what it's like an average day as a product designer, what you do for the product sites?
Well, in my role, a product designer works with the site producers and site managers to establish layouts and information architecture and graphics for the sites to make it easier for the customers to know what's going on with the products. The average day for me starts pretty early. I'm up at about 6:30 in the office. So I sit down and take a look at the last day's requests and establish what I'm going to be doing for that day for graphics.
And did you do anything else at Microsoft before you did this?
Well, I actually was an audio designer for quite a few years in the early and mid-90s. I worked on kids titles, and from there I also worked as a producer on MSN.
So kids titles like Magic School Bus?
Magic School Bus, I did the audio for Magic School Bus.
Really?
How the Leopard Got Its Spots. So those were a lot of fun.
And what did you do for MSN?
MSN, I was a producer. I was a site producer. I worked with show producers to establish the look and feel for the front page of MSN when the customers would sign in. So it gave me an opportunity to work with other producers to establish a look and feel for the customers.
Okay, so it sounds like you've been at Microsoft for a long time, doing a lot of different jobs.
Yeah, it's definitely not boring. I try to reinvent myself and reinvent what I'm doing every few years just to keep it fresh.
So you said you do audio engineering. Do you have a background in engineering or design? Did you study that in school?
Well, in school I was a disc jockey. I started out as a disc jockey, and I worked my way up the ladder through there through audio design, audio engineering. I produced some radio shows, and so audio, 20-year background in audio has been kind of the basis for my design background. And from there I moved on to visual design and web design.
So what were some of the themes of the radio shows that you disc jockeyed for?
Well, we had a school. Every school has a radio station in our area. I lived in Eugene, Oregon, and I would establish basically a theme for that show and worked from the 6 to 10 time slot, playing the hits of the day, as it were. Prime time, the hits of the day. We play it. We basically pump it through the cafeteria, so everybody was having their coffee in the morning. I'll be spinning the tunes, as it were, and so we get requests, and it was a lot of fun. It gave me an opportunity to just get my feet wet in the audio field.
So what do you like to do outside of work? Do you carry some of these interests into your hobbies outside of work?
I do. It's kind of hard to get away from design. I'm thinking about it all the time, whether I'm here at work or I'm watching TV at home. I'm always trying to come up with interesting things that'll apply for not only work but my daily life. Outside, I like to, it's actually kind of a strange hobby, but I write, direct, and produce independent horror films.
Really?
So that's how I kind of keep my mind active in other areas.
Are there anything that you have out in production?
Well, no, it's extremely low budget, kind of sub Blair Witch. So nothing distributed, but especially with titles like Blades of Death, it's just, those don't jump off the shelves. So.
Yeah, and Blades of Death 2. And
right. I'll have the sequels.
So what are some of your favorite horror films?
Halloween is one of my favorite horror films, and there's a lot of slasher films that they showed through the 80s that are pretty much schlock, but they're entertaining.
Like
and
Freddy Krueger?
Yeah, right. Friday the 13th and those they're fun, but they give you ideas, and they give me ideas to be creative and coming up with new ways of presenting visual design and audio design.
So what else do you like to do outside of work?
Well, I also help friends and family kind of set up their own home theaters. I go into people's houses, and they're always looking for something that can replicate what they're seeing in the theater on a smaller scale, obviously. So I try to help them with equipment setting up, and I'll do wiring for them and do testing for them so that the movie-going experience is replicated in their house and as close as it can be. So that's a lot of fun for me.
So you can come to my house next time.
Sure, she'll help you set up.
So Gary, where do you see, or where would you like to see your career go at Microsoft? You've done a lot of different jobs. What do you think is the next step for you?
Well, all of my jobs have focused on the customer and improving the customer experience. It's really difficult for me to get away from that, and I think that's a good thing. I try to, every day I work on new designs, and everything I do, I put myself in the place of the customer. I think, what would the customer think? Would they like this? It's pretty easy to look at your own work and say, well, that's good enough. I like it, so it must be good. For me, though, I want to know that the customer likes it. So outside of work and at work, the customer focus helps me plan what I'm going to be doing next. So Microsoft is so customer focused anyway that it's difficult for me not to see myself in any role that involves visual audio design. Mm-hmm. Like I said, I worked as a producer, and that gave me a whole new perspective of how customers use our products. So I don't know. I don't think that there's any real limit. I'm excited about what I do here, and so I'm looking forward to stuff that comes up.
That's great. Well, Gary, thanks for joining me today. It's been great.
Thank you. It's been my pleasure.
And that brings us to the end of another episode of the .NET Show.
And stay tuned for next month's episode where we'll talk about ORM.
ORM, what's that?
Well, you'll just have to wait and find out.
Okay. And until then, we'll see you on the web.